the last place we were was this HTTP server lab that we did this past March. And what we did with it, I'm just rehashing the tail end, is connected this web server up to the rest of the network proper, or rest of our LAN, and made sure that it functioned the way we wanted it to function, made sure that things out on the internet, like our home PC, for example, were able to access that web server and access our company's web page, ABC Plastics webpage, www.abcplastics.com. So we had a bunch of tasks in order to make that happen, including physically cabling it up, providing IP addresses, creating some NAT translations, a static NAT translation, network address translation, so that users on the internet could hit a public IP by arriving at our router on our public-facing interface on our router that I'm hovering over here, and then get translated to a private IP. Part of the purpose of that is for security, to protect our interior assets, and the other part of the purpose is that a device on the inside of the network that needs to be reached from the outside of the network they'd have to hit a public IP to make it happen. They could never hit our private IP addresses by the rules and courtesy of the internet and the way it operates. So we had all those tasks, and then on the tail end of the last training, we also double checked our work, because this engineering server that sits in one of our LAN segments, it had some special rules on this router to make sure that nothing could telnet to this subnet, to this VLAN or subnet, from other network segments, like the IT network segment or the accounting segment. Basically, engineering wanted to make sure the only telnetting that would happen would be within this network. And when we rehashed it on this router, I mistakenly actually made a couple of mistakes that I was looking at the recording today, and I'm very disappointed in myself. I did not rehash the rules correctly, and I did not correct them correctly. I really sort of butchered it, and I was disappointed and embarrassed in myself for doing that. So if you watch the recording for part 4, know that the very tail end, maybe the last 5 minutes or so, and I know Justin and Dennis and maybe others will recognize that tail end of that conversation. It's probably a little fuzzy because it's a couple months ago. But if you go back and look at that recording, I really botched it. I had said, oh, well, we're missing our deny any at the end because we have this permit. And that's not entirely accurate. When I changed this to a deny IP any, I basically, by virtue of the only rules being in the entire ACL were denies, everything was denied. I completely botched that. So that was totally wrong. And when I did my checking to see if things were working, for example, I tried to come from this PC to something inside this network. I used ping instead of the telnet, which was the purpose of that lab. Hey, make sure, this was 2 or 3 labs ago. Hey, make sure no one can telnet from outside the subnet. So I completely botched that. I must have been in a rush or tired, or I don't know what it was. So my apologies if anybody picked up on that. You surely didn't correct me. So if you happen to rewatch that, you're going to see that we collectively we really botched it. So my apologies. So quick rehash of what we've done to this point. We started with a router and some switches and 3 LAN segments that we called accounting, engineering, and IT. And we made sure that we could route between them, and that was about it right out of the gate. So that required building virtual local area networks, VLANs, that spanned from these PCs locally all the way up to the router. And so did this one, and so did this one. So as you can tell, the connectivity between these on this one single physical link is partitioned or broken up into multiple virtual interfaces and virtual paths for the traffic to go. And it's the way that the traffic is kept separate. So the only way you can get from one LAN segment to another is by way of this router. There's no way to go there directly through these switches. It simply isn't logically possible. We've created the rules that did not allow it. And then later on, I think we added this engineering server at one point. And then we added an internet connection, and then we upgraded our internet connection. I think we did that last time. As a matter of fact, that's right. That was part of our lab. We did that last time. Excuse me. And we tested it, and then we added the server and all that fun stuff. Or we did it 2 times ago, maybe. In any case, I know we upgraded to an fiber-based internet circuit as opposed to the original cable modem we started with. So little by little, we're growing and building our network up. At this point, before we start into the next thing, the next part of our series, does anybody have any questions, or is there anything specific that I may have forgotten that perhaps we should rehash or look at, or you had a question on, or you didn't understand, or I've skipped over something and now I've confused you? Feel free to speak up. Anyone? All right, I'm looking at my list of attendees. Looks like we're up to about 10 of them now. Well, I see one duplicate in there, no big deal. Sometimes these systems can be a little squirrely. So, all right. So let's jump in to the next piece of the puzzle, the next fun. We thought we were going to get to it last time, but we did not, which was this ticket. We had ticket number 3, I think it is. Yeah, because we did section 6 or chapter 6 or whatever you want to call that, module number 6. So now we need to do module number 7. Let's jump in there. All right. And as you may recall, every time we fire up a new module, it's sort of like you've turned all of the machines and all of the internet and everything on for the first time. So there is some degree of MAC learning and spanning tree learning and listing and all those fun things that takes place. I like to use that little magic fast forward button down there to sort of accelerate that. But we know going out of the gate, when we first start pinging things or communicating with things in our little network universe, there's some delay there as a function of the ARP learning that needs to take place and some MAC address learning and those sorts of things. So no big deal. We just know to expect it. So let's look at what's being asked of us here in ticket number 3. A DDoS attack was detected on your network last night. Does anybody recall what a DDoS attack is? What does that mean? Besides what does it stand for, what does it generally mean with regard to us and the network? Anyone? For those of you that don't know me, you will learn quickly that I'm willing to stare at the screen and wait for an answer. So definitely have somebody speak up. Here we go. Jerry is having some trouble with connectivity. I know I'm on a pretty hardened network on my side, so I don't think we have any network issues over here. If anybody else is having problems with throughput or the audio or the video. Yeah, so Jeremy, I couldn't hear you. Let me try to unmute you. All right, Jeremy, try to speak now and see if that works.
Can you hear me now?
I certainly can.
Okay, was the question what was a DDoS attack? Was that the question?
That is it.
Yeah, so a DDoS would be a denial service attack, a distributed denial of service attack that the main goal of it is to disrupt your service.
I see what you're saying. Yes, absolutely. Absolutely. And thanks, Jerry, for clearing that up. I just misunderstood what you were saying there. I apologize. Yeah, exactly. So it is distributed. It's not a single device that's doing it. So a DOS attack, a denial of service attack, typically considered one device somewhere in the universe, is trying to do something or send traffic to our network in some way that it utilizes or chews up all the resources or takes care of all the bandwidth so no one else gets any. It essentially helps deny services. It could be against DNS servers. It could be against web servers. It could be against interfaces on firewalls or routers. Depends on the type of traffic, the type of attack, and there's lots of different ways to shape that attack. Distributed denial of service, as Jeremy was saying, it's more than one PC, and it's accomplishing the same goal, but from many different PCs or other computer-like things, servers, whatever. You could even launch a DDoS attack from multiple routers if you wanted to. It's no rule that says it must be from a certain device type. Anything that can communicate on the internet, it typically is able to do that. I'm going to do the whole answer my questions here so that it's easy to see when you pipe another question in there. So yes, that's exactly right. So we had a DDoS attack last night, and obviously we got to start thinking more securely, right? That's the wild, wild west. As soon as you get off of this interface right here on our router, man, it's the wild, wild west. It's the wide open internet. It is not a safe place. It is not for the faint of heart. So we have to think about that. So our new HTTP server that we had just stood up the last time we met has had thousands of connection attempts relentlessly from thousands of different sources on the internet on many well-known TCP ports. Interesting. You need to implement an access list that denies all traffic from the outside world headed toward that HTTP server, that's our web server 1 that we put together, except for HTML traffic. So if anybody's trying to connect to do anything other than web, we don't want it to be able to even to get to the server. We want the router to say, you ain't getting through here, and just deny or drop that traffic. So, got to do an access list. And we've done a couple of access lists already, so this is no problem for us. We just got to work our way through the logic. And they want us to test the configuration from the home PC by using Telnet to try to reach the outside address of the HTTP server from well-known port numbers. That'll be our means of testing, is it really broken, and then did we really fix it? Ensure that the web server is only running processes and accepting connections for HTTP and HTTPS, or HTTP secure. Also be certain that the ACL does not block connections that are initiated from a PC inside the network to outside resources, say 68.188.0.2, for example. So we need to be careful that we don't build this ACL in a way that accidentally restricts traffic headed out to the internet. So that's a big hint of what not to do. And I've unmuted you, Jeremy. You're fine to be unmuted since you don't have any background noise, but if you want to manually mute yourself in the portal, you can. I noticed you're unmuted and it's not hurting anything, so just wanted you to be aware that you're unmuted. All right, so let's see. Why don't we do this? Why don't we start with, is this thing really working the way they describe it to be working? Let's take a look at this server real quick. And in the services tab, we can see that the first service option or service set or available services is HTTP, and we have it on for HTTP and HTTPS. And then if you recall from our prior classes, we actually have the HTML file, the HTML code in here. It's exceptionally simple. It pins up that very simple page that just says ABC Plastics Company and so on and so forth. But let's see, let's go back to this. So we want that on and we want that working. We do have DHCP turned off, which is probably a good thing, as well as version 6 for IPv6. But TFTP is on, and DNS is off, syslog is on, AAA is off, NTP is on. A lot of stuff's on here. SMTP and POP3 for email are on. FTP is on, and we'll leave the last of those three out of it. But those things alone represent potential risks to us. So let's do FTP as an example because it's what I would consider a workable example. If we wanted to use this server, if we felt this server could serve the purpose of holding on to, say, images, operating system images for different network devices, which this thing is a repository full of them, we could use it in that manner. However, because this device is reachable from the internet by design, that puts that stuff out there for other people. Well, we don't want to give those images out for other people. For one reason, we're probably not authorized to do so by the owner of those images, which would be Cisco in our hypothetical example. And two, you could have all kinds of problems like denial of service attacks if you make these services available. This was meant to be a web server, so let's lock it down to being a web server. But before we do, let's test and be sure that it's really broken the way our lab describes it to be broken. Does anybody have any ideas? I mean, it kind of gives it in the instructions, but tell me what I need to do to test to see if it's listening and available for FTP. What could I do? Use your words. Need you to talk.
Couldn't we try to connect to FTP from the home PC to see if it's still open and available?
Yeah,
over the internet?
Yeah, I think so. I think that's a logical test. We have control of our home PC. We consider it part of our universe. And we should have the ability to just telnet. So let's use the telnet command. First thing, can I even reach that website? Let's try that. I need to assume I don't know, just in case. Ping www.abcplastics, if I could type, .com. And like I said, the slowness we see now is slower than you see in the real world because we've sort of turned our entire universe on just a few minutes ago. So some ARP happening, all that learning happening. It's going to be a little painfully slow at first. There we go. The DNS finally happened. And when we say abcplastics.com, DNS says, oh, that's 24.217.0.3. Very cool, very cool. But now it's timing out. Is it timing out because something's broken, or is it timing out because it's learning? Turns out after 2 timeouts, it was just some learning things that were going on. So no shock if we have gone try to surf to the web page. I'm clicking the browser there. It would have gone real slow. It maybe would have even timed out. Again, not a very realistic part of the scenario, so I appreciate your understanding. Nothing fancy, nothing special, just a thing about a thing, but we know it works. So let's go back to what Jeremy just said. Let's get this command prompt going, and let's try to telnet. Let's see, 24.217.0.3, whoops, .3. Now, how can I telnet trying to do FTP, though? What do I do? Do I type FTP, or what do I say?
You have to do the common FTP port.
Yeah, absolutely. So one of the hints that was in here was thousands of connection attempts from different sources on many well-known TCP ports. So maybe what we need to do is let's pop open a browser window real quick. You probably need to see it on the same screen. Yep, you should be able to see the browser here. And I'm going to stop this. And I'm just going to go to good old-fashioned google.com and see if google.com can tell us stuff. Now, you can use any browser you want. I happen to be using Chrome. You can use any web search engine you would like. I just happen to be using Google. They're conveniently available. Nothing more to it than that. So I'm just going to type if I can type well-known port numbers, and the internet knows, because lots of people have searched for these things, that this is what we want. We want a list of the TCP and UDP port numbers. This is not the best or most comprehensive list, but it's one I've been to before, so I'm familiar with it. I'm just going to go to Wikipedia. No rule says we can't. Anybody asks, every network engineer on the planet uses Google or things like Google to help them do their job. So we're going to do the same thing. So you said, let's use well-known port number. Well, it looks like 20 and 21 work for FTP. 20 is a control port, and then 21 is a control port for the commands to, hey, I want to transfer stuff. And port 20 is where the actual data, destination port where the data would get transferred, so to speak. So let's try port 21. Let's see if that works. When we last looked, the server had said, yes, I am on for FTP. So in theory, it's quote unquote listening on TCP destination port 21. Anybody that comes calling to get in the door on that particular port should be allowed to get in. Let's test that theory with our home PC. So I'm going to say telnet to that IP address, but don't use the normal telnet, which is 23 by default. Sorry, or highlight. But let's use 21 instead. So put that back up because it's better for our eyes to see it this way. Can I establish a connection on port 21 to that IP address? And as you all recall, this gets statically translated, network address translation, to our inside IP address. And if you don't remember that inside IP address, I don't blame you. It was 2 months ago. It's okay if you don't. We can always look it up if we want to know. But for the sake of our test, we don't even need to know, right? So I'm going to hit enter. And the first thing it says is, oh, you've got an open connection. We have a connection established. Now, we can't transfer files because inside of the telnet utility, the commands for making FTP happen aren't very clean. You need a proper FTP utility of some kind, whether it's a command line oriented or some sort of graphical interface. But that's okay. The point of the test is still accomplished. We are able to open traffic, open a communications channel to what's represented by 24.217.0.3, which we know is that URL, but on port 21. So in theory, someone can establish an FTP connection from the internet to that server. And if we look at web server, we're not even requiring a username or password. So everybody on the internet right this minute could be grabbing files off of here or putting files on here, even worse. Could be a huge security hole, or is a huge security hole for us. So it's open. Now, unfortunately, it is really hard to just cancel and stop the connection. It just doesn't play nice, doesn't want to work. And what I have found is it's just easier for me to turn this PC off. Whoops, cancel that. Just to turn the PC off, virtually speaking, to kind of regain control of our console. So I'm just going to turn it off. not ideal. In our little virtual universe, we're certainly not hurting anything, but at least this way I can get control of my command prompt back. So, all right, so we successfully were able to telnet to port 21 for FTP. I'm not even going to try any of the others this minute. It's not that important. We, in principle, know that it's not just limited to HTTP like we wanted. So what's our next step? What do we got to do next? I'll put that PC away for now. What should we do next to get things locked down and behaving in the manner in which we would like them to behave?
So we'll need to get in the router and start creating an access control list for that web server, or for the port on that web server.
Yep, absolutely agree with you. So let's do that. Let's jump in the router. I'm going to put web server away for now. And we will pin this up here like so. Go to our CLI, our command line. And we are in privileged executive mode on this router. And if I do a show IP access lists, I can see that we have a couple of built. We have one called engineering security, and we have one called private to public overload. Those should ring familiar to you folks. And if you look at this ACL, sadly, there is something missing. One of the things you probably noticed consistently is corrections we make on the fly in our modules don't show up downstream on the further modules. And that's because I'm a doofus and I don't clean up my mess. It's not a perfect training environment, but it's really close. So you would probably recall we had to add a fourth permit statement, a fourth line to this access list to ensure that our overload translation took place, so that web server 1, like any other device on these networks, could talk to the internet, could initiate a conversation to the internet and get responses. So we should fix that very quickly. Let's double check. What is the IP address of our web server? 172.31.0.2/24. So we know that it's that subnet. Show IP route. The 31 subnet is here, and it's connected on interface VLAN 31. Show run. Let's go down and look at that interface and make sure we've got that set up properly. Okay, good. We at least have the IP NAT inside, which is good. We wouldn't have been able to talk to it from the internet if we didn't. But we definitely need to add that line to this access list. So let's do that real quick before I forget. This is just cleanup. It's not the purpose of the lab, or this particular lab, so please bear with me. So IP access list standard. Copy paste, private to public, and let's add a line. Let's add, let me see, do show IP access list. I think these are numbered if I'm not mistaken. Yes, so let's add line 40. I'm going to type 40 even though you don't have to say permit 172.31.0.0 inverse mask for /24. And I'm actually going to add a 50 deny. This is standard, so deny any, and that's it. All right, show access lists. There we go. That deny any was implicit already, but I'm adding it for logging purposes because then we can see if things are getting denied. So this is just for the overload. This is just for traffic initiated from within the network headed to the internet. Whoops, to make sure that we get a response. That was not supposed to do that. All right. So that was some cleanup we needed to do, but we still need to create an ACL, a new ACL. So let's make a new ACL. I'm going to go to global configuration mode, configure terminal, and we're going to say IP access list. Do we need to do standard or extended? Any guesses?
I think we'll want to do extended.
Yeah, why is that?
Oh, the reason he's dropping from the head.
That's okay. Don't worry about it. So looking at our two examples, we have an extended example. We have a standard example already in play. So standard really just manages by IP address, and that's it. But you'll notice that extended lets you change to TCP or UDP or IP, and it lets you focus on destination ports. This is one saying, hey, allowed or denied traffic from any source, denied TCP traffic from any source to any destination in this range if it's telnet traffic. That was the whole don't let someone from outside our segment telnet into our segment. So yeah, we're trying to specifically only allow ports 80 and 443, the two well-known port numbers for HTTPS. I should have saved that for a question for you guys instead of answering it for you ahead of time. There's HTTP, and way down here is HTTPS, right? So we need one that can let us be that granular. So yeah, extended is absolutely right. Your instinct was absolutely correct. And we have to give it a name. Let's give it the name DDoS, just because why not, right? Now we're in extended named ACL configuration mode. Let me get my network back because I like to see it next to me when I work. So do that every time. So let's see, what do we want to do first? First, we want to, how do we attack this? What do we want to do for our list? Do we want to permit traffic, deny traffic? Do we want to be more specific, less specific? What should go first instinctively? What do you think?
So we'll probably want to have a permit for the web traffic going first. That way, whenever we have web traffic coming in, it hits that first permit and it allows it through.
Yeah, your instinct's absolutely right. And our example of the other extended access list really does the same thing. The most specific traffic, the most narrowly defined traffic is typically what you want to hit first with your rules before you hit other things. So yeah, let's say permit, and we have a lot of choices of what we can permit. But we know it's going to be TCP traffic because it's specifically HTTP and HTTPS. Those are applications that would like to run over TCP. So what source addresses should we specify for this permit statement? We're allowing traffic to get to that web server, come from outside to that web server. So what sources do we want to allow?
So that would be any source, wouldn't it?
Yeah, absolutely. We're making this web server available to the whole universe. So of course, any source we consider permitted. Maybe down the road, we identify very specific blocks of IPs or things like that we want to deny. But for the time being, yeah, everybody on the internet is allowed to do the web surfing to our web server. So yeah, any source. And we can specify now destination. So what destination do we want to have for this rule?
That would be our destination to the web server.
Absolutely agree. As you recall, there's sort of two IPs represented here that represent the destination server, or the web server, excuse me. We've got the global IP 24.217.0.3, and we've got the private IP or local IP of 172.31.0.2. So which one do you think we would want to match on?
We would want to match on the local IP.
So let's do 172.31.0.2. And I'm going to hover over this to make sure that, in fact, that's the right IP. Make sure I didn't get it wrong. Yep, 31.02. Okay. All right, cool. And then we're going to specifically only match that one IP. So we need wildcard bits for a single IP. What would those be? Do you remember? So what's the inverse mask for a single host?
Isn't that all zeros?
It is. Because a subnet mask, a regular subnet mask for a single host is all 255s. So the inverse mask is all zeros. Yep. And I'm still using my question mark. We would say equal, established, greater than, less than, not equal to, a range. What port numbers? It's all about port numbers here. So what range or what ports do we care about? I'm just going to say equals. And we've got anything from 0 to 65 to 135, but we were very specific in what we cared about, right? What do you think? I think 80 is...
You're asking for the permit. There would be, so if we're wanting to permit HTTP traffic, so it'd be port 80 for that.
Agreed.
To allow the port server.
Yep, agreed. So I'm going to say equals 80, which is World Wide Web traffic, or HTTP. But we also have to do HTTPS by the instructions they gave us. So it's an exact similar permit statement. It's identical permit statement. Instead of equaling 80, we would equal what port number?
443.
443. Yep. All right, cool. So now we have do show IP access lists. Now we have two statements in here that allow traffic headed to port 80 and traffic headed to 443. You can see on the screen that www replaces the 80 because they kind of have a shorthand to make it easier to recognize some of the traffic. No big deal. Just a handful of them. But we know that's 80, so we know it's doing what we want it to do, and we should be able to test against that, no problem. The way we can test is, can we get to the web page, right? So what else do we need? Do we deny all other traffic, or what do we do there?
Well, there is already an implicit deny, but we should put the deny in any anyways, just for logging purposes, right?
Yeah, it does not hurt. Let's see, deny IP any. It's IP because we're not specifying TCP or UDP. So let's just say deny IP any, and hit enter. All right, well, now we've built an ACL. What do we do with it?
We will have to apply it to the port that the web server is on, right?
All right, so that's a really good question. That's a good point. We talked about this when we built some of the ACLs in the past. Standard ACLs have a best practice of where you want to apply them. Extended have a best practice of where you want to apply them. And you know what? Even I can't remember what they are. Let's jump into Google real quick and just see what Google says about that. So let's go back to home, and let's just say, what is it? Best practice extended ACL. Let's see what they say. So here is an example, not the world example, but an example. Skip through all the parts about applying the ACL. Cisco best practices indicate that this should be applied early in the sequence as possible. That's not what we care about. We care about what interfaces. Where are you hiding interfaces? Okay. So basically, as close to the source as possible. That's not how they say it here, but basically that's what they're driving at. So as close to the sources of traffic as possible. So that suggests that we should put the ACL where? What's the source of the traffic we're considering and giving consideration to in this particular exercise?
So that would be the Class Ethernet port or the gigabit. I don't remember which port it would be, but the port that's closest to the web server. So
the source of this traffic, when you think about it, is anybody out on the internet trying to do the web, right?
Yeah.
Destination.
Yep.
Yeah. So best practice says we want to put on our fast E0/1 the internet facing interface.
Yep, you're right.
No worries. All right, so let's look at how to do that. So if I go to interface fast Ethernet 0/1, do show run, make sure I know what configuration is on that interface so there's no surprises. Looks like we've got an IP address, IP NAT outside, and that's about it. Nothing else special happening there. So how do I apply it? Let's see, IP ? Specify access control for packets. Use the term access group so that you don't confuse it with access list or access class or access something else. So show or IP access group. Then it says, okay, give me the name of the list that you want to use. Well, DDoS is what we named it, right? And then it says, okay, do you want to use this ACL for inbound packets or outbound packets? Remembering that this is the internet facing interface and we're trying to put this ACL as close to the source as possible. Which packets are we trying to filter with this ACL? Inbound or outbound to this interface?
So that would be inbound coming into our network.
Yep, coming into us from the internet. So we'll say in, and then we'll hit enter. All right. Now, question is, does it work? All right. So let's go back to our PC, and let's make sure we can get to our web page. We have permit statements in there. Let's make sure we can get there. abcplastics.com. And it's just humming along and humming along and humming along. Request timeout. Try one more time. Oh, could be me not being able to type too. Let's see, it's just sort of grinding away. Not getting a warm and fuzzy feeling. No, request timeout. Feel like something may have happened. Let's go to our router, show IP access lists. And our DDoS has 40 matches on the deny. Interesting. So I can't get to the web page now. We sort of broken the web page. Let's try the telnet like we did before. Can I telnet to 24.217.0.3 on port 21 like we did before? Nothing happening. Okay, it timed out. And we've got 52 matches on the deny. So right now, everything that's trying to get to the inside of our network is getting denied, even though we built this ACL trying to permit traffic. What could be wrong here?
Could it be another ACL conflicting with the one we built?
No, the reason we know it's not is because we are seeing the denies increment on our DDoS ACL. Because we put in that explicit deny IP any like you suggested, we can tell that that's the list that's blocking us, I believe. I think that's our problem. That's our pain point. So let's relook at our rules here. We said permit TCP, because HTTP is a TCP string, from any host to the host 172.31.0.2 equals port 80 or port 443. Could our problem be there? Let's see, Jerry. I'm sorry I didn't see you pop in a second ago, Jerry. Let's see. Need to use the public IP for the server. The ACL is assigned to the correct interface. So Jerry's saying, I think it's just that we need to use the, yeah, I probably also have you. Is that Jerry? Let me see if I have you muted somehow, Jerry. I didn't think I did. Oh, it says self-muted. No worries, no worries. You can type it. That's good enough. So I think you're right, Jerry. So what I think is happening is, if you look at the show run and we look at that interface, fast Ethernet 0/1, essentially what's apparently happening is we're hitting our ACL before we get translated. So the traffic is trying to get in on 24.217.0.3, hits the ACL. The ACL says, well, I'll permit anything that's headed to 172.31.0.2. It doesn't know anything about the 24.217.0.3. So it never even makes it to the NAT, the static network address translation that we built last time. So yeah, why don't we do that? Why don't we change our ACL, show IP access lists, config T. Let's change the ACL instead to use the public IP, because it really appears that NAT happens after our ACL. So first we got to go through the ACL, then we would get NATed. So let's try the public destination IP instead of the private one. So let's do IP access lists, extended DDoS, and I'm going to rewrite line 10 to permit TCP any host, any to host 172. Nope. Just got through saying the public IP 24.217.0.3 equals port 80. And we'll go ahead and rewrite 20 to be port 443. A little cheating there. So end show IP access lists. Okay. Oh, that's not supposed to do that. So I've got to clean this up. Let me do this. So for those of you that can see the screen, instead of replacing line 20 and line 10 like it should do, it appears to be a quirk of the software that it simply added those lines. I was under the impression that those would replace. So either I'm a dummy or something works differently than I thought it did or something to that effect. No big deal. We are network engineers. By golly, we can fix anything. So let's do this. Let's take our ACL and just completely rebuild it. And we'll get rid of all those problems. And life will be good. Oh, that didn't work. I forgot. You can't use Control C and Control V in here. You got to use Control Insert. No, that's paste. Oh, shoot. I can't remember what it is. So I'm going to go old-fashioned right-click and copy. There we go. So let's change this to the public IP, 24.217.0.3. Do the same here. 24.217.0.3. I'm going to select all, Control C to copy, and then I'm just going to get rid of that ACL since we've got the internet broken at the moment, or our web server broken at the moment, and executives are calling furious and angry at us. What have you done? Why have you broken the web page? We're losing money. We're losing millions by the minute. So no IP access list extended DDoS. Okay, it's gone away. Now we can build this happy friend the way we want it to be with a shift insert. There we go. Now we have a proper ACL, show IP access lists. That's better. So permitting TCP traffic from anyone to the host 24.217.0.3 for port 80 and for port 443, and then deny all other traffic of the universe. So we have no matches at the moment. Let's see if we can generate some matches. So let's try to do telnet again, because it's already here. It was already handy, and we're nothing if not lazy in this business. It's timing out, and we have denies. So that part of the ACL seems to be working. We don't want to be able to hit FTP or port 21, but we do want to do web surfing to that web address, abcplastiques.com. Boom, web page pulled up. Life is good. Let's try HTTPS. It might have worked, I can't tell. Let me close it and reopen it. I don't know if we actually built code for HTTPS, https://www.abcplastics.com. You think I would have checked that? Yep, we do have it. So 80 and 443 are working, and I bet we've got matches on them. That's a very good time. I think we accomplished the goal of the ticket. Are we good here? Or is there anything left undone by chance? Or what do you think? Let's do this. Let's router 0. Let's do this. Let's pull up our friend PC8 in the IT department, and let's try to ping our DNS server of 68.188.0.2. Now, there's no real reason why we wouldn't be able to ping it, because we've been able to do it. They're doing their DNS for us. We've asked them to do DNS for us. As you recall, we had a conversation about how the internal hosts were getting the public IP for DNS for that web server, and we kind of had a little wrinkle we had to work out there that was for a later session. But you know what? No, we are not getting to the internet, or we're not getting back from the internet, one of the two. Let's try to trace to that 68.188.0.2, that DNS server. See, first hop, I'm able to hit my gateway. Second hop is timing out. Well, the only thing that's changed is the addition of an ACL. Look at this. I'm incrementing denies. I can see where on the other ACL for our private to public overload, we're getting that translated. Show IP NAT trans. Yeah, we're getting translated. I can see it right there where I'm trying to head to 68.188.0.2. But we are not getting a response back, most likely. Why would we not be getting a response back from the internet? What have we done?
Did we not allow local traffic to talk to the HTTP or the web server? I'm sorry.
No, we're not preventing local traffic from talking to it. In fact, let's try to prove that just to be on the safe side, because it's a good thought that you had there. Let me just try to ping 172.31.0.2. Remember, we don't need to use the translated public or the public address, right? Because we're internal, just like that server is. Can I ping it? Why, yes, I can. So no, the issue isn't that I can't talk to the web server, because that's all local and that's all pre-translation. The issue is when I talk to the internet, it gets out there, but it's not coming back. And as an example, let me try to ping that 68.188.0.2 again, or trace. I guess I'm tracing to it, but it's still ICMP, right? Look what happens in our access lists. I continue to increment my deny IP any on my DDoS ACL. So what's happening is, yes, we're denying traffic from the internet trying to hit our web server or hit anything internal when it's not port 80 or port 443, but that also means any traffic that we initiate internally destined for the internet, the responses are also getting blocked by that deny. So that's not working quite well for us. Is that making sense, everyone? We sort of got ourselves into a bit of a conundrum here, didn't we? If it doesn't make sense, let me re-explain it or draw the picture on here or something, because I want it to make sense or we can't move forward and our brains aren't going to work properly. Anybody have a thought on that? All right. Silence means it makes sense to you. You can always email me on the side if you look at it and go, no, I don't know. Let's see. Someone is saying, hey, Hunter, but I don't see it on the... Oh, that's way up there. Never mind. Okay. Sorry. You'd think I know how to work this question and answer by now. I'm a doofus. Okay. So let me... Let me get my magical draw the world tool that I was supposed to have set up ahead of time. With my apologies. Please forgive me. Put this little guy here. You can't see what I'm doing, but I'm making lots of noise, so it sounds like I'm super busy. I'll put this cable over here and plug it into here. And hopefully I can get my drawing action going here. So let's do a quick capture of this pretty little feller. And let me pin this up so that we can walk through it. Because I'm not convinced that you're convinced, and I'd rather you be convinced. Or that I be convinced that you're convinced. Or something to that effect. All right, so what had happened was, see if this functions the way I would desire it to function. Yes. Okay, so we built an access control list. That is not a drawing tool. We built an access control list and we put it right here on this interface. Okay, and we established pretty conclusively that it was for inbound traffic and that the ACL gets processed before the static NAT rule. So before the destination address of 24.217, sorry for my sloppy handwriting, .0.3 gets turned into 172.31.0.2. Before that even happens, you got to get through this ACL. ACL says if you're headed to this server on port 80 or 443, oops, 443, then you're allowed. Anything else, deny. So great, everybody from the internet that's trying to get to us, not surfing our web server over here, very poorly drawn circle, is going to get denied, and it protects us. But any traffic that initiates from within the network trying to talk to the internet, when the internet tries to talk back, it's going to hit this ACL and get denied. So we've got to find a way to block traffic headed to the web server, unless it's specifically HTTP or HTTPS, these fellows right here, but still allow the return traffic to come back. Because basically what we're saying is, look, if I initiate the conversation from one of these PCs down here, well, it's okay. It's all right. I've got an established conversation. It's all right to let that traffic back in. But I don't want any stranger conversation, some Joe Schmo out on the internet here on his super secret hacker PC to be able to, let's see, make it an angry face. I'm a mean hacker PC. We don't want that person to be able to initiate a conversation to really anything inside our network. Now, to be honest with you, we are capable with the equipment that we have on hand to stop that bad traffic. But what is a piece of hardware that is much more suited to controlling and filtering this traffic than what we're using? What's better than a router to solve this problem?
It would be a firewall would be more suited.
Yeah.
Rather than trying to use an ACL.
Mm-hmm. Yeah, firewall is a much more purpose-built appliance for the goal we're trying to accomplish. But we're still a small business, network. We're still learning. We're still growing. So, and it's a good intellectual exercise regardless. So we're going to go with the ACL. But yeah, firewall would totally be more suited to this. So then here's the question: how do I allow return traffic but deny the other stuff? I mean, we've already solved for let the web surfing commence, and it commences well. We can get to it from our home PC. So let's go back to the router and our topology, and let's put our heads together and see if we can't come up with a solution. So I think what we need to do is we need to work our way through the commands that exist in our command set. And honestly, Mr. Question Mark is the best way to do it. So let's start by removing the line that is causing things to be broken for right now. Agreed? Oh, wait. Jerry, see, I didn't see you pop in. I apologize, Jerry. I'm always a minute behind you, Jerry. I don't know why. We can use established state to solve this. That's exactly right. And Jerry, you picked up on the hint that I was dropping, which was it's an established conversation. That's exactly right. So let's see if we can't ferret that out of our command set. Now you can Google it or do a command reference search, but let's just see if we can find it. So let's get rid of the offending line first. I want to get that one out of the way because it'll make me actually no, we don't have to do that. Let's just wedge a line 25 in there. Let's do that. So IP access list extended, named DDoS. Oops, I don't know how to type here. And I want to have a line number 25, and it should allow me a line number. Sequence number, so 25. And then everything else is just like what we see up here, right? Same syntax, same format. So let's say before we deny all of everything, let's figure out how to allow established traffic. So it's an allow, right? So it's still a permit. Agreed? So let's say permit. And it's really any traffic. We don't know if it's going to be TCP or UDP or what's our hosts here on our LAN segment trying to talk to out on the internet. Could be DNS, could be whatever. Let's just go ahead and say all IP traffic. And we're specifically talking about inbound, right? So we're specifically talking about traffic coming from the internet universe headed towards our local networks, our local segments, right? So that means just like before when we did for the web traffic, we need to say any host for the source. Anybody on the internet can get to us, but only under one very specific condition. So what about destination? Well, it could be return traffic for that PC or that PC or that or that or that or that or that or that or that, or shoot, it could even be from our router or switches. So instead of specifying a bunch of subnets, I think it's okay to say it's still okay to any destination, this return traffic that's coming back, mind you. But we need to do something specialer. Oh boy. I don't see what we need here. There's no DSCP, there's no precedent. There should be an established, maybe it's only available on a standard ACL, although I thought it was available on, where's our web surfing? Yeah, maybe we need to use a firewall after all, because I don't see a means of cleaning that up without, in fact, their example they offer here on the CBT Nuggets website is to permit everything. Well, gee whiz, I was hoping to only permit established conversations. I don't like that. I don't like it one bit. Go back to my topology. So, I don't know. Why not just Google it? Cisco extended ACL permit established connections. Let's see what it says. Maybe they say you can, maybe you can't. Don't know. We're about to find out. I like to right click and open a new tab so I can look at the other options in my search. It's personal preference. You don't have to do it, but it's a thought. I don't think you can do it with IP. It has to be TCP. Well, gee whiz. I wonder why that would be. I think you're onto something there, Jerry. Can you have an established conversation in UDP? Does UDP specifically establish conversations?
No, you can't. UDP is only best or one way.
Yeah, it's kind of like that.
It doesn't.
Yeah, it's like a one-way thing. It's not a full conversation. It's not an established conversation at all. So even the old man here has to knock some rust off. Let's back up and look at that. UDP is probably going to be allowed anyway. I don't know. Or maybe it gets denied because that's the nature of what we're trying to accomplish. So let's do that. TCP from anywhere on the internet to anywhere in our network. Again, this is inbound on that internet-facing interface. And look at there, established, because TCP tracks the conversation. Thus, you can see in our NAT translations how it tracks the conversation, shows source and destination IP address, but also source and destination port numbers. These are established conversations. Yeah. So there you go. Let's allow anything to anything as long as it's an established conversation already. And that's what using that keyword means. I mean, they don't really explain it well here, but that's essentially what they're saying is we're allowing it, but only if it's already part of a conversation we know is going on, that we're in a sense that we're tracking. So let's say that. Let's end it and let's just show IP access list. Make sure it went where we wanted it to go. Good. So I'm permitting web traffic. I'm permitting secure web traffic only to my web server. I'm permitting everything else TCP as long as it's pre-established conversation. Then I'm denying everything else. So based on that, pretty picture. Back to my other pretty picture. Bear with me, folks. Okay. Now, let's see if we can't get to, I want to ping it quicker. Can we ping it? Let's see if we can get through this ACL now. Timed out. Timed out. I'm not feeling warm and fuzzy. I'm incrementing my my NAT translations. That's happening. Show IP NAT translations. And there's my host. I guess I'm 10.0.0.3, right? Let's see, PC8. Yep, 10.0.0.3. So the translation for us is happening, the outbound translation, so that the world sees this as .2. That part's happening. So that should be allowing that return traffic to come back to us. Boy, I can't believe these are still sitting out here. We haven't tried to do anything from home PC in a long time. I thought those would age out. Oh well, not going to concern myself with them. So NAT translation is taking place, but I think I'm still incrementing. Yeah, 119. I'm still incrementing my deny. Why is it not hitting this? That should be an established conversation, best I can tell. I tried to talk to that destination. That's probably why. Because it's not TCP traffic. It's ICMP. It's a different flavor. So guess what? Ping and traceroute are not a good test. let's do a DNS lookup, since that's our DNS server and that's the functionality we really care about. Let's do a DNS lookup. Let's see DNS. What is it? How do you flush DNS? I forget. It's all right. Let's do NS lookup. And our server is already established here. So let's ask our server, hey, what is the IP address of www.abcplastics.com? And see if we can get an answer. I'm not very encouraged by the performance of this machine. Yeah, it's still incrementing. It is not getting through. Well, I know in spirit we've definitely tried to do the right thing here. But I'm admitting to you, yeah, it's timed out. It's not getting there. It's not getting through. It's definitely hitting that ACL. And you got to remember, this is an inbound ACL on that interface, so it's not like our request is getting stopped on the way out. It's the reply that's getting stopped on the way back in. It is not fun at all. Show IPNet translations. And there's our DNS request, destination port 53. Oh, because it's UDP. Ain't that up. It's not TCP. I should have known it. It's DNS. It's going to be a UDP. Merciful heavens. So what we basically have is we have a scenario where we've kind of backed ourselves into a corner. We either need to dump this deny and permit everything, knowing that we're still wide open to the internet, or this stuff's not going to work. Or we got to write a dozen rules to account for DNS traffic, or this other traffic, or this other traffic. In theory, there's web pages out there that we would want to hit, not our web page, but some other web page theoretically that would never get back to us as well. So, sort of smells like firewall time to me. In the meanwhile, we have to get our functionality restored, and we've relieved the pressure of the DDoS attack on our web server by only allowing but when we permit everything else, we're going to open that wide open again, aren't we? Okay, so there's one other option. Anybody have a guess as to what would be smart for us because we're in this odd situation? It really goes back to what somebody said earlier.
We could always just have the internal hosts or get the website from an internal IP rather than going out to the internet and then back in.
So that is an option, but it still doesn't solve for, but what if I need to DNS, but what if I need to hit a web page out here? You know, it would only take care of us here, which is great, but that doesn't solve for the permanent use case. So what I think we need to do is the opposite of what our best practice said to do, what my instinct said to do. We need to move our ACL closer to the web server, which is not ideal, but at least that way we have more control over the traffic and where it's going and not going. Hopefully that makes sense what I'm saying. So if we take this ACL, instead of putting it here, we put it over here, I think that sort of sorts out our issue. Does that make sense?
And then since that would be after NAT, we would have to change those IP addresses as well, correct?
Yep, that's exactly right. That is exactly right. So we'd have to account for that too. So why not? We have the time. We slotted 2 hours for this. We've got the time to spend on it. Yep, it bends your brain a little bit. And actually, it's not as I planned it in my head, but I built these modules a long time ago, and this is the real world. This is how it works in network engineering. If you make a living this way, stuff just does not go to plan, no matter how well you plan it. There's plans, and then you get the first time you get hit, there goes your plan. So we don't care. We roll with it, and we got the time to roll with it. So that's what we do. And we're even smarter than that. We're doing it all in a virtual environment so that we haven't actually broken the whole internet and we go to internet jail. So that's a good thing. So let's do that. Let's rewrite this ACL. Let's go ahead and get rid of the old no IP access list extended DDoS. Let's get that bad boy out of there since we've broken our traffic. And let's rewrite this to do what we really want it to do. So I'm going to grab all these. And, excuse me, control insert, copies, shift insert, pastes. Where's mine? There we go. And obviously we want to get rid of this junk because it does not meet syntax and it will have an error. Get rid of this. We can now get rid of this. Now I'm going to leave that in there in case our web server has a purpose for talking to the internet like DNS. Well, DNS won't work. That's UDP. Well, let's take it out for now. It still means it leaves a little bit desired. We haven't accomplished what we wanted to accomplish. But like you just said, 172.31, 0.2. Gosh, if I could type, I'd be a rich man at this job. 172.31.0.2. And deny everything else. Not perfect. It's a little unpretty-ish, and it's not the best place to put it. And the reason it's not the best place to put it is it requires the router to do more work to actually have to route first and then process ACL. If we put it on the other interface, it gets to drop traffic before it hits the routing plane or the control plane, so to speak, for routing. And it saves lookups, fib lookups, and routing table lookups and all that. But in our less than perfect environment is what we got. And this is the difference between enterprise class network configuration and building and using purpose-built appliances and kind of that, basically your home network on steroids because you have a small business. This is literally the kinds of compromises you make when you're working on a very tiny little budget for a tiny little business, and you learn as you go, and you put the Band-Aid over the Band-Aid over the Band-Aid sometimes. This is not a crazy, like, oh my gosh, you would never see this in the real world. Shoot, yeah, you would, and worse. So it's a really good learning experience. So let's create our ACL and paste that in there. What we need to do is we need to take it off of interface fast 0/1, I think is our internet interface, right? Isn't that what we said? Double checking. Yeah, take it off fast 01 and put it on fast 000, or maybe that's the wrong interface. Let us discover. So no IP access group DDoS in. Don't need that inbound anymore. Let's go to your interface fast 000, which is the one that physically plugs into our web server. IP access group, what? We can't type it. Oh, man. We can't put it on the physical interface. Do show run. Why? We went over this last lab. Fast Ethernet 000 is a switch port. It is not a routed interface. It is a switched interface. What do we do? Where are we going to put this list? Is it even possible?
I don't think so, because we wouldn't be able to make that a routing port, would we, and still have this functioning?
Well, good question. You're exactly right. We can't change the configuration on Fast Ethernet 000, but there's a subnet that this server lives on, the 172.31.0.0/24 subnet. It lives in a broadcast domain. It just turns out that broadcast domain is not bounded by that physical interface. It's bounded by something else.
Oh, it's bounded by VLAN 31.
Exactly, your SVI, interface VLAN 31. Remember, the SVI, the switch virtual interface where the IP address exists, is different than the VLAN definition. A VLAN is a broadcast domain by definition, virtual local area network, where an interface VLAN 31 or an SVI, switch virtual interface, is the actual routed interface. So don't mix those up. But yes, you're exactly right. So if I say interface VLAN 31, can I say IP access group? Why, yes, I can, DDoS. Now the question is this inbound or outbound? How do we look at that? It's a virtual interface, not a physical interface, so it's a little harder to make that determination. You have to sort of sort through it logically. Anybody have a guess? Do we want to do inbound or outbound?
I still want to say it's inbound because it's still coming from the internet, getting that translated and then going to the interface VLAN.
I think you're right. If we were putting it on the physical interface, we would definitely say outbound. We would definitely say as it's going out of the router across that interface. But in the case of this SVI, it's a little different. Remember what the SVI represents. So we've got our server. Let me get my drawing action going here. We've got our server physically connected to a router. I'm drawing this really big on purpose. There's Fast Ethernet 000. And then here's his interface, whatever it was. And that fast Ethernet 000 is magically connected inside this router to this VLAN 31. VLAN 31, I know that's not real readable, but you get the gist of it. And in a sense, somewhere in this VLAN 31, in this virtual universe, exists an interface, VLAN 31. So from the purposes of the routing aspect of it, it's going to be traffic that's coming into our fast ETH 0/1, getting routed across the routing plane of this device, and then introduced into this broadcast domain by way of interface VLAN 31. So yeah, in that sense, it is inbound into the SVI. Now that is my belief, and that is instinctively what you said. I think that was Jeremy that said that. That should be right. However, let's put it in there and double check it, because for all we know, we're idiots, and it's really the SVI is kind of over here and it comes into here, and somehow, but that logically is exactly backwards to the way I believe these machines operate. So I think we're right. Let's try inbound and see what happens. Worst case scenario, we get it wrong. We learn a good lesson. Hopefully we remember it. Let's see here. Go back to this fellow. So we're going to go inbound, like you said. And we should be happy. And I think that is all we have to say there. Yeah, that's it. Okay, so let's exit out of there. I said exit. End. How about end? There we go. Show IP access lists. Okay, there's DDoS. Just like we defined it with the internal, because like you said, the NAT's going to take place now before it even crosses. I mean, when you look here, the NAT's taking place way back here before it gets to go through, get ingested into the rest of the router, so to speak, for lack of a better way of saying it, right? So let's try to initiate some traffic and see what happens. First, can we get to it from the internet like we always wanted to be able to? Let's double check that. Please, can I go to www.abcplastics.com? Not a very happy time. Request timeout. Can I even ping? Oops, that's NS lookup. Control C, Z, X, go away, exit. Ping www.abc, hey, come on, abcplastics.com. Oh, I'm on PC8. That's part of my problem. You big dummy. That was the test from home PC. So silly. We remember, we knew we had a problem with the website internally because we're not getting a good DNS entry, internal DNS entry, so my mistake. However, it's still not working. Let's go here. I'm getting denied, and I don't like it. Can I ping? That's PC8. I gotta close that before I keep making that mistake. Can I ping 24.217.0.3? Can't even ping it, and I bet you it's incrementing on the deny. It sure is. I don't like it.
Ping is ICMP traffic, right? Would that deny any catch that?
Yes, but you're absolutely right. So the ping is not a good test. However, even the web traffic is getting denied. We can see it incrementing. Let me see. How do I clear access list counters for DDoS? All right, show IP access list. Okay, no denies, no nothings. Let's go again. It's the web surfing that's supposed to be allowed by the rules we wrote. www.abcplastics.com. Waiting. It's eventually going to time out. All I have done so far is try to web surf. I'm trying to get through this permit. And notice that all of my surfing attempts were denied. It makes me think maybe we do have it on the wrong thing. Maybe it should be out instead of in. It's kind of the instinct that I have here. I hate to say it, but it sort of feels that way. So let's try that because it's an easy thing to change. Let's do IP access group DDoS out. Do show run. See if I have to take the other one off. I may have to. Yeah, sure do, because you can have one of each, but no more than one of each. So no IP access group DDoS in, which is what we tried first. Show IP access lists. Clear. Where's my clear counters? DDoS. Okay. And it can't hurt to try it, right? Boom, boom, boom. www.abcplastics.com. Boom, web page came up. And we got matches. So what that says is, remember when we were talking about this? Basically, it sort of goes with that second piece. Basically, we had to make it an outbound rule instead of an inbound rule. So it's kind of like, I'll be honest with you, that in so many ways feels illogical to me. But basically, you hit this router. Let me redraw this. And thank you for bearing with me. I know some of this is either I'm going too fast or I'm boring you to sleep. So thank you for patiently bearing with me. I don't like the pencil. I want a better drawing tool. Give me a brush. Let me see how my brush draws. So we got the server. Oh, that's so much better. We got this giant router, so I have room to draw pictures. We've got our fast Ethernet 0, 0, 0 interface. That is a switch port and lives in VLAN 31. So it's a part of broadcast domain VLAN 31. So let's call this little thingy, this virtual construct, virtual local area network 31. We've got our routed interface on the 24 dot something network. And we've got a routed interface inside VLAN 31. That is our SVI. That's our interface VLAN. And this may not be the most sensible way, but this is the way my brain logic works. So I like to go through it this way because it helps me understand it better. Essentially what we're saying is traffic comes into this interface. It gets routed. It says, oh, okay, so here's my IP interface, and you're trying to get to what destination? Oh, let me clean up that destination for you. You're really trying to get to 172.31.0.2. So there's that inbound static NAT, right? Then it says, okay, I got to get you over to the 31 network. Well, inside of me lives a broadcast domain, or I participate in the broadcast domain of this 31 network. So I'm going to get you over here. And then as you get into here, before you get switched, you have to hit this IP first. You hit the IP, and then you go out. And then because it's connected to this physical interface here, it must, in that sense, view it as an outbound rule coming out of the IP. It's so counterintuitive to me. That seems like the total opposite of what I would expect it to be. But that's got to be what it is, because it looks like it's working correctly. We have to go validate that. But that's sure how it appears, isn't it? Oh, that's stinky. Hey, I don't write the rules. That probably merits a deeper level of research. And understanding the way those pieces and those components work is definitely beyond CCNA level understanding. That's clear. That's well into CCNP territory, which is awesome, because we're smartering ourselves faster than maybe we even intended to, which is super cool. So we are able to surf there, and let's try HTTPS. I think it worked. I can never tell. It doesn't refresh very cleanly on their little rendering. So that worked. And now let's try the purpose of our whole test to begin with. Can I get to port 21 on that web server? It's trying. It did not immediately open like it did when we started this fun game. Remember, way up here, it opened right away for us. Pardon me, it even hung up the computer. I told you it was a weird quirk of the software. And boom, my FTP attempts were denied. That's a pretty good sign, wouldn't you say? I think our ACL is doing what we want it to do, however poorly constructed and poorly placed it is. It does the thing we want it to do, which is really a good thing. Show IP access list. What else can we look at? No, that's it. Okay, I was hoping to see more data, but that's okay. So we can't FTP, even though, remember, we never turned off FTP here. It's still on. We can't DHCP. We can't TFTP. I don't remember what TFTP well-known port number is. Why don't we check it just for fun? Oh, my well-known port numbers went away. Well-known port numbers. Go back to the list. What did I say? TFTP? That is it's not that far up the list. Where are you hiding? Control F. TFTP. There it is, right in front of me. Port 69. It's on. So let's see. Your home PC. Let's try. We're listening on 69. The server is listening on 69, but man, that ACL, that router is doing its job. Deny, deny. There was 12. Now there's 24. Deny, deny, deny. So that's a really good sign. So let's go back to the description of the lab. Tester configuration, try to reach the outside address from well-known port numbers. We cannot. Ensure the web server is only running processes and accepting connections for HTTP and HTTPS. So we need to turn all this junk off. Even though we're protected by the ACL, let's turn this crap off. DNS off, syslog off, thank you. AAA off, NTP, that needs to be off. Email, please turn off. It's not an email server. FTP, please turn off. So we're doing the things we were asked to do. Now, also be certain the ACL does not block connections that are initiated from a PC inside the network to outside resources like the DNS server. So let's double check that we haven't broken something. We shouldn't have, but let's be sure. Can I ping, and let's look up www.abcplastics, whoops, gotta spell it right, .com. And I immediately got an answer that this is the address for that URL you gave me. And I got the answer from my web server, or excuse me, my DNS server that lives out on the internet. So even that, and there should be nothing logged on that ACL particularly, yeah, no changes, because we didn't even cross that ACL. That ACL kind of lives over here-ish. That's a bad way of saying it, but you saw my cute picture, so that gives you the story. So I think we accomplished our goal. The only downside, the only bad part is technically I can't do DNS from here. NS look up. I've already got it configured for that 68.188.0.2. Look up www.abc. Actually, there should be a cisco.com entry in there too, if I'm not mistaken, in that DNS server. And it's going to time out. So that's the downside. And you'll see it incremented that deny again. 25 matches. So, because if there wasn't an entry for it, it would say, you know, I don't have an answer for you. It would answer almost immediately. I'll show you. Cisco.com. I don't know that one. www.cisco.com. Don't know that one. So it's immediate when it's working right. It's just unfortunately, it's not working. So that's a problem. But that's not one we're going to be able to solve here. So I think we can let that ride for the time being. A little research, and I bet we come up with a solution. And or, yeah, you got to use a firewall when you get into a complex set of rules for protecting your network, but allowing the stuff through that you want to allow through, all that good stuff. At this point, we've done a bunch of things, and we've drawn pretty pictures and all kind of great stuff. Does anybody have any questions for me? Any thoughts? Anything we maybe missed, didn't cover that you wanted to cover? Silence means you're falling asleep, or I've answered everything in the universe to you. So I think what I want to do, because we have a little time left, but I know we can't get through an entire lab, is let's just sneak a peek at what part 6 we'll probably begin with, so that we have an idea of what we're going to be up against. It doesn't hurt to do that. So I'm going to save this as our work from today. 20210524. Just so if we want to refer back to it in the next class, we have the ability to do that. I should have been doing that all along and probably wouldn't have such a mess on my hands. But let's look at the next ticket real quick before we adjourn. I've already saved the network. Go away. So we did ticket 3 just now. You can see it up here at the top. Pardon me, I'm sorry. Let's go to this one called support. What in the world is support? Loading, loading, boom. Holy moly. Look at this beast. So that HQ LAN that we were just looking at, the router, which was up here before, and the 4 switches and the aggregation and our 3 VLANs and all their fun, that now has been bundled up into this cute little HQ LAN cloud. There's our web server still there. There's our router. Bet you we got some rules miswritten because I didn't clean that up. I should do that. And then we've got this whole other thing. There's a router out here called support router. This one has been renamed HQ router. I don't think we called it. I think it was just router before. And it's got a switch hanging off of it with a department called contractors. Ooh. Another one with one called management. Interesting. And some PCs and a lot of instructions. We've decided to open a second facility called support in Milwaukee. Budget to purchase a router, 2 switch, and frame relay circuits. How cutting edge are we? We got a frame relay circuit. Yeah, and there's a whole frame relay cloud network thing happening here in the middle. Super archaic, super antiquated, still a really good lesson learning experience piece of the puzzle. I don't think they even ask frame relay questions anymore on CCNA exam at all. That's okay. Nothing will do with frame relay would you be compelled to memorize, but it still accomplishes part of the goal, which is, hey, we got to get from this location in Texas to this location in Milwaukee. We've got to buy circuits from a carrier who can provide that connectivity. We're starting with frame relay because that's just how it is. So we can buy circuits. We got to put WICs and routers. We've got to do these things called DELCs, which are basically circuit identifiers. And it told you to use connect to this and connect to that. You've picked a couple of VLANs, VLAN 20 and 22 with some IP blocks, 172.20 and 172.22, kind of sticking with the theme that we've done so far, or very close to it, right? And we've got this /30. Remember we had a conversation about subnetting last time, and everybody said they were good and they didn't need a deeper explanation of subnetting. So you should be able to tell instinctively what a /30 is for and how many IPs are available to use and all that fun stuff. And, for LAN, DHCP, and switch management addressing and all of those things, we're just going to follow the model we used at HQ, which I think implies that we do DHCP on this router like we did DHCP on HQ router. But maybe we do DHCP on HQ. I don't know. We'll have to see. We'll have to see what we want to do there. Come back to that. Configure serial connections, routers, switches, point-to-point interfaces for the definition of those serial interfaces, static default route. Why would we even need that? We'll have to figure that out. Make sure we use static routes to point from the old router to these new subnets. Why would we need that? We'll have to figure that out. And then you got to connect. You got to test your connectivity that every PC and every LAN can reach not every PC, but at least one PC in each of the other local area networks. And everybody can talk to everybody and can talk to the internet. Your new one's got to be able to get through here to the internet. So this is a really significant lab. I mean, there's enough work in there, we might not even be able to accomplish it all in 2 hours. So part 6 is going to be loaded with lots of great stuff. Hopefully everybody can come back. Hopefully everybody can get engaged and really tackle this thing. And we're even, if you note let's see. Nope, we're in fact addressing that thing where you can't get to our web server or to our website from internal. We're not addressing it here. It will be addressed in a later lab. So we're even going to solve that at some point down the road, which in a real world, you would have solved that sooner rather than later, but that's okay. We don't care. So again, we're kind of getting to the point of wrapping it up. About $1.45, $1.40, $1.45, which is where we were at last time, if I'm not mistaken, from the last recording. Does anybody have any questions? Have any thoughts? Is there something that I said that was wrong or didn't make sense or that you want to expand on? We've got time if you want. And if you're not comfortable doing it here, you can shoot me an email or something. I don't mind. Anybody have a thought on that?
I don't think I have any further questions.
Okay. Well, hopefully this has been helpful. Hopefully you gained something from it. For some of you, maybe many of you, this is a lot of rehash, replay, just relearning what you knew before and either haven't used, or just a different way of doing the same thing, or who knows. But again, I hope it's been informative. I hope it's got something that really helps you, and you're getting something out of it. I know I enjoy putting them on, especially enjoy when we can have the conversations and talk through this. And I didn't have all the right answers all right away too. We had to fight through it together. You got to Google answers. You got to rewrite ACLs, replace ACLs over here and over there. Definitely a part of the game. This is very real world sometimes, when either you have a funky network put together, you have a really tight budget, you can't buy firewalls, for example, or you could have a leadership that maybe they have an archaic view of the network universe and they want to do it their way. I haven't run across that too much, to be honest with you. Most of us are pretty cutting edge, but it does happen, especially in some, small business that's just a smaller outfit like that. You may run into that. So this is not entirely, oh yeah, you would never see this. Oh, yes, you would. Don't be surprised. Even frame relay, while it's a stretch, there are frame relay-like things that are out there still running to this very day. So as much as everybody wants to get off of them. So yeah, it's definitely got some real world elements to it. So, all right. Well, I appreciate everybody's time. Thank you for your attention. Thanks for the questions. Thanks for the conversation. Again, shoot me an email if you have any other questions, or you have a thought or something you want to see, or something we didn't cover well or didn't cover effectively or even correctly. I'm open to the feedback and I appreciate it. And I hope everybody has a great day, a great week, and stay safe out there and enjoy your summer. We'll talk to you soon. Bye.